absolute value equations and inequalities. So this is read the absolute value of x. Those two bars on the outside are the absolute value symbols. And one way to interpret that is the distance between that number and 0. Distance is always measured in positive numbers, so this always makes x positive, no matter what it was before. You can kind of think of it as stealing a number's old sign and replacing it with a positive. So whether it was positive or negative, it's positive now. So the absolute value of positive 4 is positive 4. The absolute value of negative 2 is positive 2. It doesn't switch the sign, it makes it positive. Alrighty, we got a couple DIYs for you. Okay. Absolute value equations. So here we have something that reads the absolute value of x is 2. And what that's saying is, what is x? We know it has an absolute value of 2. What has an absolute value of 2? Well, there are two possibilities. 2 has an absolute value of 2, and the absolute value of negative 2 is also 2. So there are two solutions, and in fact, most absolute value problems have two solutions. There are very few exceptions to that, but let's just go with, if you've got an absolute value problem, expect to have two solutions. So in this case, x equals 2 and x equals negative 2 are both solutions. So sometimes we would write that as x equals plus or minus 2, just as kind of a shortcut. Again, remember that the absolute value of x is always going to equal a positive number. If it's set up to equal a negative number, it is a trick. They're trying to fool you, and there is no solution. Nothing can make what comes out of an absolute value negative. Okay, we have a couple of DIYs for you. A little bit more complicated. Maybe there's some extra stuff. So the basic strategy, get that absolute value all alone, and then you can figure out what it equals. So here, the absolute value of m plus 1 equals 3. I'm going to subtract 1 from both sides. Now I have the absolute value of m is equal to 2, which means that m is equal to positive 2 or negative 2. Similarly here, I have 4 times the absolute value of q is 12. I need to get that absolute value alone. So I now have that the absolute value of q is equal to 3, which means that plain old q must be either positive or negative 3. Now we've got a couple for you to do. Oh boy, this time there's some stuff inside that absolute value. Okay, here's the solution, or the strategy. You're going to make and solve two equations. So you take the stuff that's inside that absolute value, and you set it equal to the other side. Remember that that other side is going to be a positive number, because nothing can make an absolute value negative. So if it's negative, then it's a trick and you just write no solution. You're also going to, for your second equation, take the stuff inside that absolute value and write that it's equal to the negative of the other side. The reason we do this is we don't know whether that stuff used to be positive or negative. It would work either way, so we have to try both. We have to show both ways. So here I'm going to take this stuff, u plus 3, and first I'm going to say it equals 2. I also have to set up another equation. U plus 3 is equal to the negative 2. Okay? Alright, I'm going to solve for you now. Subtract 3, and same over here. Subtract 3, subtract 3. So u equals negative 1, and u equals negative 5. Let's just test this really quickly to make sure that we're not full of baloney. So, the absolute value of u plus 3 should equal 2. So let's try negative 1. The absolute value of negative 1 plus 3, that's, well, negative 1 plus 3 is 2. The absolute value of 2 is 2. Great, let's test this one. The absolute value of negative 5 plus 3 should equal 2. So let's see, negative 5 plus 3 is negative 2. And the absolute value of negative 2 is 2. Cool, cool. I've got 2 for you to do now. All right, if we put it all together, what do? First, you get the absolute value all alone. Isolate that absolute value symbol. There's going to be stuff inside, but get that symbol all alone. Then make 2 equations. The stuff inside the absolute value is equal to the other side, and the stuff inside the absolute value is equal to the negative of the other side. Solve both those equations and check both of your solutions. So I would suggest that you see if you can do these. I'm going to do them, but you might pause and see if how you do on them, and then check your solution against me. Here I go. I see here that I have minus 4, so first I'm going to add 4. I'm trying to isolate that absolute value first. So now I have the absolute value of j plus 1 divided by 3 equals 2 plus 4 is 6. Okay. I still don't have that absolute value alone. I've got this divided by 3, so I'm going to undo that by multiplying by 3 on both sides. So now the absolute value of j plus 1 is equal to 18. Okay, now I've got my absolute value all alone. I'm going to make my 2 equations. Oh my, I'm running short on room. So j plus 1 equals 18. And the other one is j plus 1 equals negative 18. To isolate j, I'm going to subtract 1 from both sides. So j equals 17. Negative 18 take away 1 is negative 19. J equals negative 19. Okay, let's just test this. 17 plus 1 is 18. The absolute value of 18 is 18. Divided by 3 is 6. Take away 4 is 2. Check. All right, negative 19. Negative 19 plus 1 is negative 18. The absolute value of negative 18 is positive 18. Oh shoot, that's my cat. Excuse me a minute. Ah, no, go away. Yeah, cats love math. You didn't know that? Okay, where was I? I had a negative 18 inside this absolute value. I'm checking negative 19. The absolute value of negative 18 is positive 18. Divided by 3 is 6. Minus 4 is 2. Great, they both work. Okay, how about this one? First, I need to isolate that absolute value. So I'm going to take away 3 from both sides. I get 2 times the absolute value of m minus 3 equals negative 2. I still need to isolate this absolute value. I'm going to divide both sides by 2. So the absolute value of m minus 3 equals negative 1. But wait, absolute value can't ever equal a negative number. This is a trick. No solution.